It's like hunting with infrared goggles in a world where everyone else is blind to infrared. The deep ocean pushes life to adapt in ways that seem impossible. And yet life finds solutions. Every challenge is met with innovation, with specialization, with strategies refined over millions of years. The result is an ecosystem unlike any other on Earth, alien in its appearance but functioning according to the same fundamental principles that govern all life. Energy flows, nutrients cycle, organisms compete and cooperate and reproduce. The rules are the same, only the conditions have changed. Energy is the currency of life, and in the deep ocean, energy is scarce. Without sunlight, photosynthesis cannot occur below a few hundred meters. Yet life thrives at depths far beyond the reach of light. Where does the energy come from? How does the deep sea food web function? The answer is marine snow. Every day, a gentle rain of organic particles drifts down from the surface. Dead phytoplankton, zooplankton, fecal pellets, molted shells, fragments of larger organisms, all descending slowly through the water column. Some particles are tiny, barely visible. Others are larger aggregates, clumps of material held together by sticky mucus. Together, they form a continuous link between the surface ocean and the deep sea. Most marine snow is consumed in the twilight zone. Fish, crustaceans, and jellyfish filter the particles from the water or scoop them up as they drift past. But some escapes, sinking deeper, reaching the midnight zone, the abyss. Even the Hadal trenches beyond 6,000 meters. By the time it reaches the deepest parts of the ocean, marine snow has been picked over many times, and only the least digestible material remains. But it's still food, still energy, and deep sea organisms have evolved to extract nutrition even from this depleted source. Sea cucumbers roam the abyssal plains, sifting sediment through their tentacles, searching for organic particles. They're like vacuum cleaners, processing vast quantities of sediment to extract tiny amounts of nutrition. Some species leave visible trails on the seafloor, tracks showing where they've fed, tracks that can remain visible for years in the still waters of the abyss. Brittle stars, relatives of sea stars with long, thin, flexible arms, also feed on marine snow. They position themselves on rocks or coral skeletons, holding their arms up into the water column, catching particles as they drift by. In some areas, brittle stars cover the seafloor in such density that their arms create a living carpet. Thousands of individuals all filtering the same slow rain of food. But marine snow isn't the only food source. When larger animals die at the surface, their bodies sink to the seafloor, creating food falls. A whale fall is perhaps the most dramatic example. When a whale dies and its body sinks to the deep ocean floor, it brings with it tons of organic matter, a sudden windfall of energy in the food desert of the abyss. The whale fall creates an oasis that persists for decades. First come the scavengers. Sleeper sharks and hagfish tear at the carcass, consuming the soft tissues. These fish can eat for months, gorging themselves, and then they disappear, their hunger satisfied. Next come the bone-eating worms, Osedax, which bore into the whale's skeleton and dissolve the bones from the inside, accessing the lipids stored within. These worms have no mouth or digestive system. Like hydrothermal vent tube worms, they rely on symbiotic bacteria housed in their tissues. The bacteria break down the bone lipids, and the worms absorb the nutrients. As the whale's skeleton breaks down, it creates habitat. Mussels and other invertebrates colonize the bones. Bacteria form mats on the remaining organic matter. The whale fall goes through several stages, each supporting a different community of organisms. In the final stage, the bones themselves become part of the seafloor, providing hard substrate where creatures can attach, structures that rise above the sediment plain. A single whale fall can support a unique ecosystem for 50 years or more, an island of abundance in the desert. Woodfalls have a similar effect. When trees fall into rivers and are swept out to sea, some sink to the ocean floor. The wood becomes colonized by wood-boring bivalves, shipworms that are actually clams despite their name. These creatures have symbiotic bacteria in their gills that help break down cellulose, the main component of wood. The woodfall creates a localized ecosystem that can persist for years, supporting animals that specialize in feeding on wood or on the bacteria that decompose it. Even smaller food falls have an impact. Dead fish, squid, jellyfish, all contribute to the energy budget of the deep sea. Amphipods and other scavengers gather around any carcass, feeding quickly before the food disappears. But some deep-sea ecosystems don't rely on food from the surface at all. Hydrothermal vents and cold seeps generate their own energy through chemosynthesis, creating food webs independent of sunlight. These ecosystems are primary producers, converting inorganic chemicals into organic compounds. They're oases not just because they have food, but because they generate food from the Earth's chemistry. The deep-sea food web is characterized by inefficiency. Energy transfer from one trophic level to the next is far less efficient than in surface waters. In shallow ecosystems, about 10% of energy passes from prey to predator. In the deep sea, that number may be closer to 1%. This means top predators are rare. Large predatory fish are few and far between, scattered across vast areas. Cannibalism and opportunistic feeding are common. When food is scarce, you eat whatever you can find, including members of your own species. Deep-sea fish often show evidence of having consumed their own kind. Survival outweighs social bonds. The deep sea is also a place of decomposition. Bacteria break down organic matter, releasing nutrients back into the water. These nutrients are gradually transported upward by ocean currents, eventually reaching the surface where they fuel new phytoplankton growth. The deep ocean acts as a nutrient reservoir, storing elements like nitrogen and phosphorus until currents bring them back to the sunlit zone. This cycling connects surface and deep ecosystems, creating a global nutrient loop that sustains all marine life. Despite the challenges, despite the scarcity of food and the extreme conditions, the deep sea food web functions. Energy flows from the surface or from the Earth's interior. Organisms consume and are consumed. Decomposers break down the dead. Nutrients cycle. And life continues in the cold and darkness, patient and persistent, adapted to a world that seems hostile but is simply different from the one we know. And so we reach the end of our descent. We've traveled from the surface through the twilight, into the midnight depths, down to the abyss, and visited the strange oases where chemicals from the Earth's crust sustain life in the absence of sunlight. We've met creatures that glow in the dark, fish that fish with lights, worms that live off chemicals and never eat. We've seen adaptations that push the boundaries of what we thought was possible. The deep ocean covers more than half of Earth's surface. It's the largest habitat on the planet, and yet it remains largely unexplored. We've mapped more of the moon's surface than the ocean floor. We've sent robots to Mars, but barely scratched the surface of what lives in our own planet's depths. Every expedition to the deep reveals new species. Scientists estimate that millions of species remain undiscovered in the ocean, most of them in the deep sea. Every submersible dive, every trawl, every video survey brings back images of creatures never seen before. Strange jellyfish with long, trailing tentacles, fish with bizarre appendages, octopuses in colors and shapes that defy expectation. The deep ocean also holds clues to life's origins and its possibilities. The discovery of hydrothermal vent ecosystems showed us that life doesn't require sunlight, only energy and the right chemistry. This has implications for the search for life beyond Earth. Jupiter's moon Europa has an ocean beneath its ice, possibly with hydrothermal vents. Saturn's moon Enceladus shoots plumes of water into space, suggesting similar conditions. If chemosynthetic ecosystems exist in Earth's deep ocean, might they exist on these distant moons? The deep ocean also provides resources. Bacteria from hydrothermal vents have given us enzymes that function at high temperatures, useful in industrial processes and research. Deep-sea fish produce salvabic antifreeze proteins that prevent ice crystals from forming in their blood. Proteins that might have applications in organ preservation and frozen food technology. The pharmaceutical industry is beginning to explore deep-sea organisms for novel compounds. Molecules evolved in extreme conditions that might have unique properties. But the deep ocean is not immune to human impact. We're already mining the seafloor for minerals, dragging heavy equipment across the abyssal plains, disturbing ecosystems that have remained unchanged for millennia. We're dumping waste into the oceans, and some of it sinks to the deepest trenches. We found plastic in the Mariana Trench at nearly 11,000 meters depth. We found pollutants in the tissues of deep sea fish. The deep ocean is not separate from us. It's connected, part of the same planet, affected by our actions, even though most of us will never see it. Climate change affects the deep ocean too. As the surface warms, it disrupts the currents that transport nutrients and oxygen to the depths. Ocean acidification, caused by excess carbon dioxide dissolving in seawater, may affect deep-sea corals and shell-forming organisms. The deep ocean absorbs much of the heat and carbon we're adding to the atmosphere, buffering the surface, but at a cost we're only beginning to understand. The deep ocean is vast, mysterious, and essential. It regulates climate, stores carbon, cycles nutrients, and supports ecosystems we're still discovering. It reminds us that Earth still has frontiers, places we haven't fully explored, mysteries we haven't solved. As you drift towards sleep tonight, maybe you'll dream of those depths, of soft lights glowing in darkness, of strange creatures floating through cold water, of vents pouring heat and chemicals into the abyss, of life persisting where it shouldn't, thriving where conditions seem impossible, finding ways to survive in the most extreme environment on Earth. The deep ocean is waiting, patient, quiet, full of wonders we've barely begun to imagine. If you enjoyed tonight's journey, consider liking this video and subscribing to the channel. It helps others find their way here to learn and the wonder and drift peacefully toward rest. Thank you for listening. Sleep well.